Right. See, now we are going to learn the expansion. How the expansion will be. Okay. Now x plus y whole power n. Now it is a binomial term. Binomial power n. I am talking about n belongs to n. So like here positive index. Positive integral index. Positive integral index. Okay. So now keep in your mind what are the things while expanding. Power is what? N. So when you expand it, how many terms will be there? N plus 1 terms will be there. N plus 1 terms will be there. Okay. So now I am going to do that one. First, NC0. NC0. First term x. X power. Here NC0, right? N minus 0. The difference. Into y power 0. Whatever the foot, it will become as 0. And NC1. Next term is NC1. So x power n minus 1, the difference n minus 1, x power n minus 1 and y power 1, the foot will be 1 will be taken as that. Then similarly nc2, x power n minus 2 and the foot is 2 and so on. ncr, this is ncr, x power n minus r, y power r and so on. Last term NCN, x power n minus n, y power n. So what I said, n plus 1 terms will be there. Okay, if you count it, if you expand it after, if you know the n value, clearly we can say that how many terms are there. Definitely one term will be extra. Now NC0, x power n minus 0, y power 0. So the expansion, once again I am going to tell you, NC0, x power n minus 0, y power 0. NC1, x power n minus 1 and the foot, y power 1. NC2, x power n minus 2, y power 2 and so on. NCR, x power n minus r into y power r and so on. NCN, x power n minus n, y power n. So this is expansion. Suppose if you have a doubt, how can I check whether you have done it correct or not? See, I said each term will be maintained the homogeneous. Whatever the power is n, the same will be their power. Now here n minus 0 plus 0, it is n. N minus 1 plus 1, it is also n. N minus 2 plus 2, n. N minus r plus r, n. N minus n, 0 plus n, n. Number 1. Number 2, here x power n, starting is x power n. Next one, x power n minus 1, x power n minus 2, and so on, x power n minus r, and so on. Last term, x power n minus n. So where you are starting? N. Where you are ending? 0. So it means when you are talking about 0 to up to n, so up to 1 to n is n and 0 is extra. So totally n plus 1 terms will become. Next, similarly if you consider y, as x decreasing and y increasing. So y power 0, y power 1, y power 2 and so on, y power n. So here also y starts with 0. 0 to n. There are also n plus 1 terms. So this is a way you can know that what are the terms will be there, how to write it, how to expand it. Clear? Next one. This expansion generally I am teaching. So moreover, if you see that expansion in your textbook, it will be in the form of x plus a whole power n. So in the place of y, a will be there. So same thing if you write it nc0, x power n minus 0, a power 0, nc1, x power n minus 1, y, a power 1. So and so on. ncr, x power n minus r, a power r and so on. ncn, x power n minus n, a power n. Don't get confused with that. See, we are talking about binomial. So later we'll learn trinomial, multinomial also we will learn. Now another thing, Pascal, Mr. Pascal gave a clarity. What is that? First term, last term will be same, right? So then what is the first term? This is nc0 coefficient. First term coefficient and last term coefficient. nc0 is equal to ncn. Clear? And another thing, if you see the similarity, first term, last term, similarly first from the first second term, from the last second term, from the first third term, from the last third term. So these all will be coefficient same. So then if you take nc1, nc n minus 1, okay, and nc2, nc n minus 2. You may have a doubt, sir, how we are writing? We are not writing this one. See, one thing, what is the here index shows that n, right? Here n, and the sum Here also should show that n only. For example, I have written 0. To balance that, I have to write n. Here 1 I have written. So then 1 for balancing, I am writing n minus 1. For suppose 2, then balancing n minus 2. Similarly, if I write NCR, then balancing is NC n minus R. Because n minus R plus R is n. So remember, similarly, from here what I can say, NCP is equal to NCQ. It means n is equal to P plus Q. N is equal to P plus Q. Remember this shortcut. Okay, and these shortcuts already we learned in permutation combinations. Okay, now see, in the permutation combinations we have learned it how to expand NCR. See, I am going to teach you now the NCR expansion. NCR expansion. Okay, so let me do here. NCR expansion will be NCR is equal to n factorial by n minus r factorial into r factorial. NCR is equal to n factorial by n minus r factorial into r factorial. Clear? Right. So what is r factorial? Or n factorial? N factor stands for, say your wish, you can start it from n and with 1, or start with 1 and with n. So I am writing always, I write it n into n minus 1 into n minus 2 into up to 3 into 2 into 1. So what I am writing, n and below the numbers product is called as n factorial. I can give you an example. 5 factorial means 5 into decreasing order 4, 3, 2, 1. See, this already these expansions we have learned in permutation combination, so that's why I am giving you here. Next, now NC0, NCN. So according to the Pascal, first and last term coefficients will be 1 only. And NC1, NCN minus 1 from the first second one, from the last second, that is n only. Remember, from the first term coefficient, from the last term coefficient, always NC0, NCN value will be 1. NC1, NCN minus 1, NC1 value is n, NCN minus 1 is n. Clear? Right. Next, how to write in a short form this one, expansion totally. See, every term in your arithmetic progression we have known that if you know that the general term, you can construct the total sequence. Am I right? Here, the general term is NCR x power n minus r y power r. This is called general term or rth term. General term or rth term. Now, I want to write all the terms. Then I write it sigma r is equal to 0 to n. Because sigma says that summation. So, and r is equal to 0 starts for position. First term 0, r value 0. So, nc 0, x power n minus 0, y power 0. So, the total expansion x plus y whole power n. This is a short form for x plus y. Suppose if they ask x minus y whole power n, there is nothing. You have to write sigma r is equal to 0 to n, nc r x power n minus r minus y power r. This still more simplification. Sigma r is equal to 0 to n, nc r x power n minus r y power r and minus 1 whole power r. So what I am taking, minus 1 alone I am taking out. That will give that the respective terms coefficients. So in general, you please remember always this expansion x plus a whole power n. So this widely used everywhere. So instead of x plus 1, you take x plus a whole power n. Okay. So if you take x plus y whole power n also, no matter, no problem. But most of the expansions are based on that x plus a whole power n. Okay, now here this is a standard and basic expansion. Here after that the constructions will be possible. N value. So far we are learning n is a positive integral index. So only it will be applicable for 1, 2, 3 as well as they are going for minus 1, minus 2, minus 3 also. So then when we are going to learn for applications, we are going to learn all the types of those questions alone. Alright. Now here, if you have two types of expansions, another expansion, what is that? X minus a whole power n. So if x minus a whole power n, what is going to be happen? Alternately, the negative will be possibility. the negative. So the negative, how it is possibility, then I am going to write it, please. So nc0 exponent n minus 0 a power 0 minus nc1 exponent n minus 1 a power 1 and so on. Then we have to write it the terms alone. Next, when you are writing at last, what you can write it, minus 1 whole power n ncn exponent n minus n a power n. It's clear. Now when you are going to addition, when you are going to do addition, x plus a whole power n plus x minus a whole power n, what I am going to do, I am going to do the addition. So when I am going to do the addition, what is happening, the alternative is the negative symbols, whatever the terms are there, they are going to close, they are going to cancel themselves. Then what is going to happen, nc0. So it will come nc0 exponent n minus 0 a power 0. And next nc0, right, nc1 code. So nc2 exponent n minus 2 a power 2. Similarly nc4 exponent n minus 4 a power 4 and so on, it will be possible. See, if I want to write it, then I want to know that nc and n value, so I cannot give the conclusion. So that's why I am writing and so on. Similarly, if you do the subtraction, x plus a whole power n, x minus a whole power n. So what is going to be happen? 2 into, here first terms will be cancelled. So second terms will be remain same. So nc1 exponent n minus 1 a power 1. Then nc3 exponent n minus 3 a power 3. And nc5 exponent n minus 5 a power 5 and so on, it will become like this. Clear? So when you are going to expand it, so it will be happen like this. Then now how many terms will be existed in these expansions? Let us do that one. Okay, here two cases will be arises. It depends upon the n value. Okay, case 1, if n is odd. If n is odd. See, if n is odd, when you expand it, it has even number of terms. So even number of terms, right? So these both are having the same number of terms. How many terms will be there? N plus 1 by 2 terms will be there. In this expansion, in this both expansion, n plus 1 by 2 terms in case if n is odd. Suppose if n is even, then expansion, it will be, in this expansion will be odd number of terms will be there. So by the time this top layer addition has n by 2 plus 1 terms, and subtraction it has n by 2 terms. Remember, this is the one formula to apply.